Hello, space fans, and welcome to another edition of Space Fan News. This week, astronomers using a novel new technique to combine data from the Herschel and Planck space telescopes have found the most distant cluster of galaxies we've ever seen. Galaxy clusters are the most massive objects in the universe, containing hundreds to thousands of galaxies, all bound together by gravity. While astronomers have identified many nearby clusters, to understand how they formed, they need to go further back in time. The light from the most distant of the four new clusters identified by the team at Imperial College London took 10 billion years to get to us, and shows what the cluster looked like when the universe was only 3 billion years old. Now, astronomers are able to see individual galaxies much farther away, and I've reported many of these discoveries to you already. Some are from a time when the universe was only a half-billion years old, so we can see individual galaxies much further away than we can these clusters. But this is the most distant cluster of galaxies we've ever seen, and the discovery is important. This technique of combining the data has potential to go even farther back. What they did was combine data from two satellites, both of which ended their operations last year. The Planck satellite, which scanned the whole sky, and the Herschel satellite, which surveyed certain parts in greater detail. The researchers used Planck data to find sources of far-infrared emission in areas that were covered by the Herschel satellite. Then, they cross-referenced that with Herschel data to look at these sources more closely. The team then used additional data and new observations to estimate the distance of these clusters from Earth and to determine which of the galaxies in those clusters were forming stars. The clusters can be identified at such distances because they contain galaxies in which huge amounts of dust and gas are being formed into stars, and this process emits light that can be picked up by the survey satellites. All galaxies in the universe are divided into two main types: elliptical galaxies that have many stars and are huge. IC 1101, for example, is the largest galaxy in the universe, and it's elliptical, but they have little gas and dust. And the other type are spiral galaxies, like our own Milky Way galaxy, and they contain lots of dust and gas. Now, most of the clusters in the universe today are dominated by the giant elliptical galaxies, and there the dust and gas has already been formed into stars. What astronomers believe they are seeing in these distant clusters are giant elliptical galaxies in the process of being formed. So while we're at it, on a related note, late last week, astronomers from the Frontier Field Survey using galaxy clusters as giant lenses through the Hubble Space Telescope found a very distant galaxy. This galaxy, named Abell 2744Y1, is about 30 times smaller than our galaxy, but is producing at least 10 times more stars. From Earth, this galaxy is seen as it was 650 million years after the Big Bang, and is one of the brightest galaxies discovered at such an epoch. This galaxy is among the first to be discovered by the Frontier Fields project, which will look at 6 clusters and make 6 more ultra-deep fields over the next 3 years. Next, this. It turns out we space fans aren't the only ones looking up. Last week, NASA's Mars Curiosity rover took time out of its busy day roving and looked up at the Martian evening sky and took a picture of the Earth and the Moon. This is what we look like in the Martian sky. The Earth was 160 million kilometers, or about 99 million miles away when Curiosity took this photo. Finally, using the Hubble Space Telescope and the Cassini spacecraft, NASA was able to get a 360-degree view of Saturn's auroras. While Hubble was looking at Saturn in the ultraviolet, Cassini, which was in orbit around the planet and much closer, got complementary views in the infrared, visible, and ultraviolet wavelengths. It shows how the auroras move and their complexity. This also allows scientists to see how an outburst from the Sun affects the magnetic fields of Saturn. Now, trying to observe these things has proven to be very fickle. Sometimes you see a great show, or you may not see anything. It turns out that 2013 was a good year for seeing aurora on Saturn. We saw everything from steadily shining to super fast bursts of light shooting across the pole. These Hubble and Cassini images were focused on April and May of 2013. Images from Cassini's ultraviolet imaging spectrometer, or UVIS, and obtained from an unusually close range of about 6 Saturn radii, provided a look at the changing patterns of faint emissions on scale of a few hundred kilometers, and tied the changes in the auroras to the fluctuating wind of charged particles blowing off the Sun and flowing past Saturn. This movie also shows one persistent bright patch of the aurora rotating in lockstep with the orbital position of Saturn's moon, Mimas, while previous UVIS images had shown an intermittent auroral bright spot magnetically linked to the moon Enceladus. This suggests another Saturn moon can influence the light show. Well, that's it for this week, space fans. Thank you for watching, and as always, keep looking up. Don't forget to join us every Friday night, 9 p.m. Eastern, 2 a.m. Greenwich time for Space Fan News Live, where Scott Lewis and I will discuss all of the week's stories that are in this episode. So I hope you guys can make it, and I will see you there.